now.
Hello! Welcome to Jess and Jackie's Science TV. We're here in Edinburgh Gardens today and we're going to teach you some things about the solar system. So just as a background, I am doing the elaborate phase for our unit on the solar system. So today I'm going to be looking at the sun and how we can measure the sun's diameter using the actual sun.
Yay!
Yay! Do you want to see that Jackie's here? Are you excited to learn about the sun?
So excited, I'm ready to go. Excited to learn about the sun.
Now, I'm just going to tell Jackie one safety requirement. Should we ever look directly into the sun? No, we shouldn't. So I'm just going to aim the camera up, although it's a bit cloudy as you can see, so this may not work. But I'll pass on over to Jackie. And Grant, hopefully I'll teach you something as well today. So all we need, it's quite simple. Okay, so I've pre-prepared, but in class I would get students to do this themselves. So you need a little piece of foil that I have attached to a bit of cardboard. And you need just a little pin or something to prick, I don't know if you can zoom in, to prick a hole right in the centre there. Okay. And then you just need, so I've taped that to the back of the paper, just a blank white page. Now, without looking directly at the sun, we need to aim this at the sun with the white piece of paper. Now, because it's about midday, the sun is pretty much directly above us. If it was over there, we would shine it that way. Over there, we would shine it that way. Now, it's a bit cloudy, so this may not work. But you aim this on the white piece of paper. No, I don't think it's gonna. The sun's gone. Okay, so we'll just pretend. I don't have a pencil. We'll just pretend. So, you're meant to see a circle. Ooh. No,
It worked
you probably won't be
earlier.
able to see from there. Okay, so roughly, it should be shine a little circle straight through your pinhole viewer, and you're meant to measure the diameter of that circle. I'm going to guess it's going to be very small from this height, about 0.2 centimetres, okay?
0.2 centimetres.
So I'm going to record that quickly with Chevin.
Excuse us for
Sorry.
a moment. Sorry, a highlighter's okay, Jess?
Maybe the sun will come. Yeah, that's perfect.
Okay.
Okay, so diameter equals 0.2 centimetres.
Do you want to hold that up there for us, Jess?
We'll get to the equation in a moment, but this is what we're going to use to figure out the actual diameter of the sun. Now, the thing is, you're generally going to need, if this was in a class, you'd have about 3 people in a group for the lesson, because you need someone to hold it and someone else to record, because you're meant to hold this in the same spot. So that when you measure the diameter at 0.2, then you need to measure the exact distance between these two papers. So I've actually just moved it and come back. But we're going to say it's about 16 and a half centimetres there.
16 and a half.
16 and a half. Okay. So, we then have our equation. So doing that, if it was a sunnier day, it would work a bit better. Okay, so we're going to figure out the diameter of the sun using the length between the Earth and the sun, which is a given, we already have that. So L is 149,600,000 kilometres away the sun is from the Earth.
Wow.
And then we've got our two, it's exciting. We've got our two numbers here. So we've got 0.2 centimetres and 16.5 centimetres. Now, just to be noted, we don't have to convert this at all, because the reason we can do this is because of the ratio between kilometres and centimetres. So we don't need to worry about converting those at all. So I'm just going to use my phone to save time, because I'm not going to work this out in my head. I could try, but I'm going to see. Just pop that down there. If you need to zoom in or anything.
You can have a
Got that?
Look at this.
Quickly do a little calculation here and see how accurate our... Okay, so we've got... Oh, I've already... Oh no. 1496. No, that's not right. 1496. 000 times... We had 0.2 divided by 16.5. Dun, 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 dun. That is very inaccurate.
Should you perhaps do the D over the L first and then times it?
Good question.
So,
maybe I can write that down.
yeah.
I did do this before in the practice and it worked though, but...
Okay. Well, let's try, do 0.2 over 16.5 and then times that by the sun distance.
Okay, so D 0.2 divided by 16.5 equals... Maybe I'll just write this down with a bit of a maths lesson here. So that, I got 0.0121 repeater, 121, 121. So that...
Repeater?
Yeah, my maths language. 49600. Okay, we can use that. So I got, our diameter, 1813333 kilometers. Okay, can you zoom in on that one? Can you see that at all?
Yep.
So our calculations aren't extremely accurate today, but in a lesson you could do this again and it creates a discussion about things that you could do better and how accurate, and you can even give a prize or something to the group of students that get it the closest. Or also you can make predictions in the starting of before you give the actual diameter and those sorts of things. As an elaborate phase, yeah, we're looking at the sun. It's been mentioned in previous lessons, but yeah, so that's the main lesson for elaborate.
Great.
Our sun hasn't come out yet, so that will have to do for today. Woo, I hope I taught you something.
Side note from...
Oh, sorry, what did you
Jackie.
think, Jackie?
Well, I really thought that was quite fun. A bit sad that the sun didn't come out, so it wasn't quite accurate today. Another idea of what you could do in a classroom setting, because there would be so many more groups coming up with different answers, you could get all the answers, write them up, then find the average and see how close that could be as well.
Excellent idea.
Just a
Thank you,
little
Jackie.
idea there from Jackie. Bye for now.
That's us
Fun
signing
doing
off.
some science today.
Bye-bye.
Bye.